More than 400 years ago, a middle-aged professor of mathematics and astronomy, who also happened to be a genius, took his first look at the sky through a telescope he had built by hand. Like almost everyone who ever lived, Galileo Galilei wondered about all he saw in the night sky. If only he could get a better view of the stars and the moon. Recently, spyglasses had been invented to magnify things in the distance, such as ships. Galileo designed a much stronger spyglass and turned it upward. Would the telescope show him things about the universe that were invisible to the naked eye? Galileo was the first human being to see the mountains and craters on the moon. Before him, people believed that the moon was perfectly smooth, but Galileo's telescope revealed surface features much like those on Earth. When he pointed his telescope at the planet Jupiter, he was shocked to find 4 small stars around it, which no one had ever seen. The next night, the stars had changed position. He concluded correctly that the stars were actually moons circling Jupiter. People had long wondered about the mysterious glowing streak in the sky, known because of its dim white appearance as the Milky Way. Maybe Galileo could finally figure out what it was. It was made up of countless stars too faint to be seen without a telescope. Galileo realized that they were suns like our own, but much, much farther away. Today we have built larger telescopes that can see thousands of times farther than Galileo's. This image was taken by one of our most remarkable telescopes. It's not on Earth though, it's in space, where the view is not hampered by clouds, pollution, or the atmosphere. The Hubble Space Telescope. Through it, we've seen things in the universe that are breathtaking. Because of our technology, we understand a lot more than Galileo could. But there remain great questions. How did the universe begin? What is it made of? How big is it? How many stars are there? What is the future of the universe? Scientists believe they have solved some of these questions, but some they haven't yet. The universe is the greatest of all mysteries, and the answers that will unlock its secrets await new discoveries, perhaps by future scientists watching this show right now. It is vast. It stretches as far as we can see in every direction. It is a place of bitter cold and blazing fire. It is beautiful. What exactly is the universe? As far as we know today, it encompasses everything that exists, from tiny atoms to the whole Earth, to the sun and other planets, to the trillions of stars and the billions of galaxies. The universe is all things everywhere. It is also an immense mystery, a source of wonder throughout human history. Across the ages, Some of our greatest minds have offered theories about the nature of the universe, often expanding on the ideas of those who preceded them. Today's story of the universe might appear strange to the great astronomers of the past. Vishwamitra in India, Ptolemy in Greece, Aryabhat in India, Copernicus in Poland, and Galileo in Italy. We are not sure how the universe came into existence. Some believe that it was created in the remote past, and others say that it has always been around. Present-day science estimates that the universe is about 14 billion years old and suggests that it exploded into being in a Big Bang. According to this theory, all of the matter in the universe may have been concentrated in a single object no larger than a marble. Suddenly, for a reason we don't yet know, it blew up, becoming a universe unbelievably hot and expanding, and then gradually cooling down. When it was born, it was all energy and gravity, the force of attraction, and some of this energy turned into what we know as matter. This primordial matter gave birth to the elements. Hydrogen and helium were formed in the first 30 minutes or so. As stars later formed, they produced the other elements. After expanding and cooling for billions of years of its infancy, the universe entered the equivalent of its early childhood. A lot of interesting things began to happen. The attraction of gravity brought some of the matter together into immense clumps, here and there. These clumps of gas and dust eventually collapsed and became galaxies. The hydrogen and helium gases in the galaxies broke up into smaller clouds. From these clouds, the first stars in the galaxies were born. Most of the stars that formed early were supermassive. But they lasted just a few million years, then blew up in catastrophic explosions called supernovae. Curiously, all the elements to form life were produced inside the hot interiors of these massive stars. When they exploded, those elements were flung out into the extreme coldness of interstellar space. The blast of these supernovae also triggered the formation of new stars, a second generation. By the time the universe was a few billion years old, it was markedly different from what it had been just after the Big Bang. The simple state of radiant energy present at the time of its formation had grown into a massive collection of billions and billions of galaxies. Some of these galaxies are spiral-shaped, some elliptical, and another stay irregular shaped, sometimes a result of colliding galaxies. Generation after generation of stars were born, produced elements for life, such as carbon, oxygen, and iron, and eventually died. As it has continued to expand for billions of years, the universe has become thin and dispersed and extremely cold. Hundreds of years ago, we believed that Earth was the center of the universe. Then science proved that our planet and other planets actually revolve around our sun. Today, we know that the sun itself is but one star among 400 billion stars that make up our Milky Way galaxy. And that our galaxy, though composed of hundreds of billions of stars, can seem insignificant when we realize that it is just one among hundreds of billions of galaxies in the universe. Our Milky Way galaxy formed about 1 billion years after the Big Bang, making it some 13.2 billion years old. The most ancient stars within it are about 10 billion years old, and the youngest are just a few million years old. In fact, baby stars are being born even today. Our sun is a middle-aged star, 4.5 billion years old. It was born from a cloud of gas and dust, which we call a solar nebula. The birth of the sun was brought about by the explosive death of a nearby star. Shock waves from the explosion of the dying star triggered the formation of the solar system. Most of the gas and dust in the cloud went to form the sun, and a small amount collected to form rings and debris around it. Most of the material in the rings then coalesced to form planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Smaller, leftover bits of matter became dwarf planets like Pluto, asteroids, and comets. Of the 8 planets, only the 3rd planet, Earth, is located in a zone where life can thrive. Unlike Venus, it is not so close to the sun that water boils away, nor is it so far away that water freezes into ice, as on Mars. Water in its liquid state is essential for life to arise and to evolve. The Earth was initially very hot, and there was no atmosphere. In the course of time, the outer surface cooled into a hard crust, encasing a core of molten rock. In many places, the liquid interior broke through the crust as volcanoes and spewed out red-hot lava and gases. These gases formed Earth's first atmosphere. One theory holds that clouds in this early atmosphere showered rain unceasingly for thousands of years, giving rise to our oceans. Another theory is that the water masses on Earth were created by impacts from massive comets, which are made largely of ice crystals. Had you been able to watch the birth of our planet from space, it might have looked like this. The solar system started condensing about 4.5 billion years ago. A couple hundred million years later, the Earth had appeared. After another 300 million years, the atmosphere and the oceans had covered Earth. Another 500 million years passed and some primitive forms of life appeared, such as blue-green algae. Another 500 million years, and bacteria and simple plants had arrived. Then, over billions of years, more and more complex organisms evolved, first in the sea and later on land. Eventually, some 200 million years ago, the gigantic animals we call dinosaurs dominated Earth, only to disappear about 70 million years ago. probably as a result of climatic changes caused by the crash of a large asteroid, setting the stage for the rapid evolution of mammals, foremost among them humans, who began to shape nature itself. Our ancestors made stone tools, used fire, and learned to farm. From wanderers and gatherers, we became settlers. As life became easier, people had a lot of time to look at the sky. In the apparent random distribution of stars in the night sky, our ancestors imagined familiar shapes and patterns, which we call the constellations. Today we recognize a total of 88 constellations that encompass the entire sky. Twelve of these are called the zodiacal constellations. Together, they form a belt running across the sky. The sun, the moon, and the planets appear to travel through the belt of the zodiac. One of the most conspicuous constellations seen in the winter sky is Orion, the hunter. A little to the west is the celestial bull Taurus, a zodiac constellation. Taurus appears to be attacking Orion the hunter. The orange giant star Aldebaran forms the eye of the bull. On the other side of Orion, we see Canis Major, the big dog, with Sirius, the dog star. Sirius is the brightest star in the sky, and there above is the puppy dog, Canis Minor, with its bright star, Procyon. Early humans lived close to wild animals, and they saw them in the night sky as well, such as the bears. There's the big bear, Ursa Major, and nearby the baby bear, Ursa Minor. As we've seen, two stars from the body of the big bear point straight to this tail star of the little bear, which is the North Star Polaris. Right overhead, we find the famous zodiac constellation Leo the Lion. One of the brightest stars, Regulus at the front paw, is actually 4 stars. And Denebola at the tail is a relatively young star. In the southern skies, we see the ancient ship Argo. Together, we have divided this ship into 3 constellations. The sails of the ancient ship we call Vela, the stern, Puppis, and the keel of the ship is called Carina. Canopus of Carina is the second brightest star in the sky. In fact, Canopus is used to navigate in the southern seas. Another constellation in the south that helps navigation is this one, formed by 4 stars in the shape of a cross. This is the Southern Cross, also known as Crux. Surrounding Crux is one of the biggest constellations, Centaurus. To the ancients, the stars were in the shape of a centaur, half man, half horse. Alpha Centauri, the 3rd brightest star in the sky, is at the rear hoof of Centaurus, along with Proxima Centauri, which is also the closest star to us in the entire night sky. Here, in the constellation Boötes, the herdsman, we find Arcturus, the fourth brightest star. The fifth brightest star in the sky is seen rising in the east now, Vega, which has been studied more by astronomers than any star but the Sun. With two other bright stars, Deneb of Cygnus and Altair of Aquila, Vega forms a famous celestial threesome called the Summer Triangle, which rises each May, signifying the approach of the summer season. At any given time, you can see about 3,000 stars with your naked eyes. A few very bright, some dim, lots of stars barely visible. There are just a small fraction of the 400 billion stars in our Milky Way galaxy. To express the vastness of our universe, we use the term light year, the distance light can travel in 1 year. Our solar system is 300 light years from the center of the Milky Way galaxy. Andromeda Galaxy, which is the farthest object that the naked eye can see, is some 2 million light years away. And Andromeda is the closest major galaxy to us. Beyond it are more than 100 billion galaxies, stretching across billions of light years. Over thousands of years, we've tried to comprehend the universe by observing it. Today, we do so using increasingly powerful telescopes and computers, trying always to formulate a comprehensible picture of the universe. One great question fascinates us. Is there other life out there? Some skywatchers exclusively search for extraterrestrial life. Recently, we've discovered that many stars have planetary systems around them. Some astronomers estimate there may be a billion places in the universe which can support life. But as of now, we have discovered no evidence of life elsewhere in the universe. As biologist and author Julian Huxley has said, there may be other beings in this vast universe endowed with reason, purpose, and aspirations, but we know nothing of them. So far as our knowledge goes, the human mind and personality are unique and constitute the highest product yet achieved by the cosmos. Man is that process of reality, said Huxley, in which and through which the cosmic process has become conscious and has begun to comprehend itself. As Huxley suggests, the universe does not exist out there independent of us. We are inescapably involved in what appears to be unfolding before us. We are small participants in a universe of extraordinary scale. Our future as a species is intimately connected with the future evolution of the universe. Coming centuries, the climate on Earth may change drastically. The continents which are drifting apart may one day collide with each other, destroying old mountains and creating new ones where none existed before. A huge asteroid could hit the Earth, as happened in the age of the dinosaurs. Some stars may die in the neighborhood, and some new ones may be born. After billions of years, the sun itself may expand into a red giant, engulfing the Earth and beyond. In the past, some astronomers theorized that our expanding universe might eventually slow down, halt, and begin to collapse. But that theory may be in question because of the recent discovery of what astronomers call dark energy and dark matter. We don't know exactly what they are, but we know they make up a large part of the universe, and discovery suggests that the universe is not just expanding but accelerating. Who knows what future generations might discover? They are likely to have an entirely different understanding of the universe than we do. As each great mystery is solved, another arises. That's the beauty of science.
Thank you for being with us. Please check your belongings before leaving the seat.